they want the maximum acceleration that's attained. So with that being said, what we need to do is find an acceleration equation. So let's start by doing A of t equals, and we're going to take the derivative. So we have 3t squared minus 6t plus 12. Now they want the maximum acceleration, maximum meaning derivative, which we just took, and we want the highest point. So I think the easiest thing to do, honestly, is just to take your calculator, throw this into your y1, and then you'll get a picture. Now when you get a picture, don't quote me on this, but it's going to look something like this. This being 3 here, this is obviously 0, and the minimum point here is at 1. So you want the maximum acceleration will be up here at the x value of 3. So you can go to your table and you can look that up, and you'll see that A of 3 is 21. Now, the other way also that you can do this is just by plugging 3 into your acceleration equation. So your answer is choice D for that one. All right, now this one gives you the position equation, and it wants the value of t for which the velocity is 0. So we need to find a velocity equation. So you're going to take v of t equals 2t minus 6, 6, and we're going to set it equal to 0 because we want to know when the velocity is equal to 0. So we have t equals, 3, which is choice C. Okay, the next one is giving you the position equation, and they want to know for what times t is the velocity increasing. So let's start by getting a velocity equation. So we take the derivative, and we get 4t cubed minus 12t. Now, this one is asking for what times t is the velocity increasing. They want the velocity increasing. So that would be the derivative of the velocity. So we need to go an extra step and find A of t. Okay, remember that increasing, that word increasing or the word decreasing means derivative. And since we have increasing here, we want the derivative of the velocity, and thus why we're taking the acceleration. So if we go an extra step, we'll get 12t squared minus 12. And we want to figure out increasing, decreasing, so we're going to want to do a sign chart for the acceleration, which is going to require us, in this case, to set your acceleration equation equal to 0. So I would probably take out a 12, we'll get t squared minus 1, set that equal to 0, and I think that you can see that this is going to be t plus 1, t minus 1. So we're going to have two critical points of the velocity of the acceleration, which would be plus and minus 1. So we go ahead and throw those onto our sign chart. And then you're going to do one of two things. You can pick values. Now this is an acceleration sign chart, so you should be plugging the values into the acceleration equation. Or if you go back and you look at this original acceleration equation, it is a parabola that's pointing up, so we should have plus, minus, plus. Okay? Now they want to know when it's increasing. Now we have two values, or two intervals, I should say, where we are increasing. We're increasing when t is less than -1. However, we are talking about time here. And also if you look at the question says for when t is greater than or equal to 0. So that's not going to work for us. So the other interval in which t is increasing, in which the velocity is increasing would be when t is greater than 1. Now, if you look at your choices there, that would be choice E. Okay, so this one is giving us a position equation right there, and they want to know the velocity of the particle at the time its acceleration is first equal to 0. So hopefully you kind of realize that in this one we're going to have to take a velocity, find a velocity equation, and we are going to have to find an acceleration equation. So let's start by doing the velocity. Okay. So we're going to take the derivative of 4 cosine of pi over 2 times t, and that's going to be negative 4 sine of pi over 2t, and then from there we're going to take the derivative of right here, that pi over 2t, which would just be pi over 2. Okay, and if we make that look a little bit prettier, that'll be negative 2 pi times the sine of, pen doesn't want to work here, pi over 2t. Okay, so there's your velocity. Now, from there, we need to find an acceleration equation. So let's take the derivative of your velocity. Alrighty, so then we're going to, I would probably, you can do product rule if you so choose, that's completely up to you. So I'm going to take the first, which is negative 2 pi, times the derivative of the second, and the derivative of sine rather is cosine. We have pi over 2t, and then we have to take the derivative of the inside, which would be pi over 2. Okay? And then we can simplify that a little bit, and you can see that the 2's will cancel out, and then you've got pi times pi with a negative there. So I'm going to write it as pi squared. I don't know why my pen's not working. And we've got the cosine, come on, of pi over 2t there at the end, and a squeeze in a parenthesis. So there's your acceleration. Now, it says here, let's reread this. So it says, what is the velocity of the particle at the time its acceleration is first equal to 0? So we're going to take that acceleration and we're going to set it equal to 0. So if we set it equal to 0, I hope that you do see that this can never be 0. It's a constant. So really what we're doing then is we're just taking that cosine of pi over 2t, and that we're setting equal to 0. So now let's think about this for a second. What value, what angle measure could we have here in this blue box that would make the cosine of that angle equal to 0? And hopefully you'll see that that would be 90 degrees, because the cosine of 90 is 0. So what we really want here then is we want this pi over 2t to equal 90 degrees. Now we're doing calculus here, so we're going to use the radian form. So then now look at that, and you should see that t has to equal 1. Okay? Now let's go back to the question again, because what it's asking is what is the velocity of the particle at the time its acceleration is equal to 0. So we found that time right down here, t equals 1. Now, last but not least, we are going to throw that into the velocity equation. So what they want you to find is v of 1, and I promise we're done after this. Okay, so v of 1 equals negative 2 pi times, and I'm looking down here at the end, okay, the sine of pi over 2 times t, but remember t is 1. Alrighty, so obviously 1 times pi over 2 is pi over 2. So the sine of pi over 2 is 1. So your answer is negative 2 pi. And here we go. That's the very final answer. And now if you look at your 4 choices, that would be choice D. All right, number 5 wants the maximum acceleration of a particle on that interval if the position is given by. Well, this is exactly like number 1. The only difference is you're going to be taking a derivative twice because we need to get the acceleration equation. So let's start with your velocity equation. And your velocity is just going to be 4t cubed minus 12t squared. Okay, now we need acceleration, so we're going to go one extra step. And we're going to take the derivative again, and we're going to get 12t squared minus 24t. All right. Now, we want the maximum acceleration. So we want where the acceleration is the highest. So you can, again, go to your calculator, put this in your y1, and you're going to get a picture. And take my word for it, your picture looks like this. And this is at 3, and this is at 1. Wow, this is very similar to number 1, and that's at 0. So again, if you want your maximum, that would be this point up here where your time is equal to 3. And if you follow that over, that will be 36. Again, you can look that up on your table. So just do second table and you'll get that. So your maximum acceleration would be when the time is 3, and that amount, that value would be 36, which is what they were asking for, which is choice E. Okay, now number 7 just wanted a velocity equation and an acceleration equation. So let's start by taking the velocity. So remember that 2 pi is just a constant, so that's like 3t or 6t or 7t. So the derivative of that would just be 2 pi plus, now the derivative of cosine is negative sine. So we're going to put negative sine, let's see if we can make that look like a sine, 2 pi t, and then we have to take the derivative of the inside there, which would be 2 pi. Okay? All right, now let's make that look a little prettier. So that would be, well, actually, I do see that they both have a 2 pi, so I'm actually going to take that value out in 2 pi, and then I'd be left with 1 minus the sine of 2 pi t, and that would be my velocity equation right here. All right, so for acceleration on part B, I'm going to take the derivative of that. I'm going to do product rule. So I'm going to take the first, which is the 2 pi, times the derivative of the second. Well, the derivative of 1 is obviously 0. The derivative of negative sine would be negative cosine of 2 pi t. Then I'm going to take the derivative of this, which would be 2 pi. And close those parentheses. All right, now what I notice is I have not 1, but I have 2 pi's there. So I'm going to bring this negative on the outside, and then I'm going to put 2 pi, and I'm going to square that quantity, because there's 2 of them, and then write the cosine of 2 pi t. And that would be your answer. Well, let's write A of t equals. That would be your answer for the acceleration. All right, last one. They give you the particle moves along the x-axis. Here's your position equation, and they want in part A an expression for the velocity. So we're simply going to take the derivative of that, and we are going to get 3t squared minus 3t minus 6. There's your answer for part A. Part B is asking for when the particle is at rest. Well, particle is at rest whenever the velocity is equal to 0. So we have a velocity equation from part A. I'm going to factor out a 3, and I will get t squared minus t minus 2, set that equal to 0, and then I'm just going to factor and solve. So that'll be t minus 2 and t plus 1, set that equal to 0, and I have t equals 2, and I have t equals negative 1. Now, we are talking, obviously, about time. Time can't be negative. Also, if you look at the directions, it says for the interval from 0 to 4. So this will cancel out, and that will be my answer for part B. Part C is asking when the particle is moving to the right. Particles move to the left and the right. We need a velocity sign chart. Now, I do know that I can't have a negative time, but I am going to put the negative 1 on there, and I'm going to explain why. Because if I look at the velocity equation in part A, notice that my t squared has a 3 in front of it. That's positive, so that means it's an upward pointing parabola, so I know my signs are plus, minus, plus. It just makes it easier for me to do the sign chart. I am going to ignore the negative sign of that sign chart, though. So I would be moving to the right when the time is between 2 and 4. Okay, so that's when the particle is moving to the right, because what we're doing is we're looking for when the velocity is positive. Okay? All right, next, part D wants you to write an expression for the acceleration. So let me squeeze that in down here. So we're just going to take the derivative of your velocity. So your velocity equation is up there in part A. So I'm going to get 6t minus 3, and that would be my acceleration equation. Part E is asking when the acceleration is 0. So we're just going to take our part D answer, which is 6t minus 3, and we're going to set it equal to 0. And we're going to get t equals 1/2. And last but not least, part F wants the total distance traveled from time 0 to time 4. Now remember, I'm going to slow down here a little bit. Total distance traveled. You always look at the interval that they've given you, which in this case is time 0 and time 4, and we want to evaluate those times at the position equation. So I'm going to do s of 0, and I'm going to do s of 4. Notice I'm leaving a space in between. That space in between, we will always evaluate the position equation, but this middle spot right here is always going to be where the velocity is equal to 0. And that we can find right here in part B. Okay, so the velocity was equal to 0 at time 2, so I'm going to evaluate the position, always the position equation, at time 2 as well. Now, we did have, remember, we had a time of -1, but that doesn't fall within the interval that was given in part F, and plus time can never be negative. So you're going to go back to your original equation that was given right here, and you are going to plug in values of 0, 2, and 4. When you do that, you're going to plug in 0, and you should end up with 4. Okay, you're going to have to work that one out and figure that out. And then for the second one down, the position evaluated at 2, when you plug that in, you will get -6. And lastly, when you plug in 4 into the position equation, you're going to get 20. Total distance, think of a number line. You're at 4 on the number line, and you walked all the way down to -6 on the number line. So you covered a distance of 10. Same thing here. Then you're going to say, well, I was at number 6 on the number line, and I walked all the way up to 20. So that means you covered a distance of 26. So altogether, your total distance should be 36.